Once again, you are welcome to Tutor-E's Chemistry Hub. And as promised, this is the final part of the question we had in the previous video. In this case, we are not dealing with mass to volume. Actually, in both cases, we have the concentration of one of the compounds, and we have to determine the concentration of the other compound. So always remember the formula you require. Concentration equals number of moles divided by the volume. So now the point is, we need to find the concentration of sodium hydroxide. We have the volume, but we don't have the number of moles. So what do? We simply have to know that, according to the question, sodium hydroxide is reacting with hydrochloric acid. So the number of moles which we are required to have to determine the concentration has to be that number of moles that reacted with hydrochloric acid. So it all boils down to stoichiometry. Even in the question, you can see what concentration reacted with hydrochloric acid. So that again is derived from the number of moles that reacted with hydrochloric acid. As we said, there are two methods. I will use the first method, which uses our regular stoichiometry. Even the other method uses stoichiometry too, but it just has a little formula that you can easily use, and you just have exactly the same answer. So the first thing, as I always do, we need to have the chemical reaction. And as has been made clear, we have HCl reacting with sodium hydroxide. Acid reacts with base, we are going to have salt and water. And if you check through, the reaction is already balanced. So next thing we do, we are given information of hydrochloric acid. So we have HCl, and we have to determine the concentration of sodium hydroxide. That simply means we are dealing with HCl and sodium hydroxide. From the chemical equation, derive the information you have first. 1 mole of HCl reacts with 1 mole of sodium hydroxide. Then the next thing is, how many moles of HCl are we given according to the question? Well, we are not given, but we are given the concentration and the volume. If you read the question, the concentration of HCl is 0.25 moles per liter. And then they said, if 50 milliliters of this solution, which solution are they referring to? That is the HCl. That simply means that this is the volume of HCl, 50 milliliters, and this is the concentration of HCl. So we already know from concentration equals number of moles over volume. To get the number of moles equals concentration times volume. So the number of moles of HCl has to be 0.25 times 50. However, you have to remember 50 is milliliters. It needs to be in liters. That means to divide by 1000. So note it that liters is practically equivalent to decimeter cube, and milliliters is practically equivalent to centimeter cube. Depending on the curriculum, these are the values you may actually see. So the number of moles of HCl, which I've tagged NC in this case, becomes 0.25 times 50 divided by 1000. And we have 0.0125 moles. So in other words, this solution we are given, it involves 0.0125 moles of HCl. So if 1 mole produces 1 mole, then 0.25 is going to produce X. In this case, you don't really need this. If it's the ratio 1 to 1, therefore, it will also be producing 0.0125. However, let's just cross multiply as we usually do. X times 1 gives you X, and then 0.0125 times 1 gives you 0.0125 moles of sodium hydroxide. However, remember, always read your question. We are to get concentration, and concentration equals the number of moles over the volume, which equals the number of moles now of NOH is 0.0125 divided by the volume, which is 40. But remember again, 40 is in milliliters, so you have to convert it to liters. When you divide 40 by 1000, you should be having 0.04. And finally, you answer the concentration of sodium hydroxide becomes 0.0125 divided by 0.04. And so you have 0.3125 moles per liters. And that is simply your answer. However, the second method you can use, because it's relating concentration, volume, and number of moles, you can easily use this. Now, if you observe from the very beginning, we had that number of moles equals concentration times volume. You can simply express this as a ratio. So what you simply have is the ratio, express them as a ratio. That means you can simply say number of moles of the first and the second, the ratio of it equals the product of concentration and volume of the first and the second. Again, they are ratios. And this is practically the formula that you have. In most cases, it is used this way: C1V1 over C2V2 equals N1 over N2. As you can see, it is practically mole ratio. Just exactly what you have been solving since. But like I said, this one now simply looks as if it is a formula. Actually, it's a formula. All right. So in this case, let's take HCl as our 1 and take NaOH as our 2. So I'll say C1, it means the concentration of HCl, V1, the volume of HCl, and so on and so forth. However, take note that your N, you get them from your chemical equation. It is practically telling you that the number of moles, the ratio of the number of moles at any point will always remain constant. CV is still number of moles. All right, so C1, that is the concentration of HCl. We are given as 0.25 times V1, the volume of HCl, we are given as 50. Now, in this case, you get to save a little bit more time. You don't need to convert milliliters to liters, because in the end, that is going to cancel out at the end. So you can simply leave it as milliliters. C2, we are looking for the concentration of NaOH times V2, we are given as 40 milliliters, equals N1 from the chemical equation, HCl was 1, and N2, sodium hydroxide, was also 1. So when we simply cross multiply, we have that anything times 1 is practically the same thing. So we can simply say 40 C2 equals 0.25 times 50. So therefore, our C2 equals 0.25 times 50 divided by 40. So you have 0.25 times 50 divided by 40, and you still have 0.3125 moles per liter. Exactly the same answer. So you can either solve it as your basic stoichiometry, trying to separate it to show that these are two different methods. So let me put or. So you can either solve as stoichiometry, or you can simply use this formula and get your answer. All right. So always remember, like, share, and subscribe. and watch out for the next video where we will not talk about limiting reagents. We are gradually getting to the end of stoichiometry. So remember, always attempt more questions. And if you have any issues, you can always contact me. I'm on Facebook, I'm on WhatsApp, and I'm on LinkedIn. Like, share, and subscribe. And see you in the next video.